Hello guys, today I will show you a simple Slinky drop simulation which I made using Python. This video only describes simulation. For real Slinkies, a link is given in the description. So without further delay, let's get started. Slinky is a spring which follows Hooke's law. It is shown on the right hand side. It is held from its top end hanging vertically. It is seen that the Slinky is more stretched on the top, having large spacings between the top turns as compared to the bottom part, because there is more mass for the top part to apply large gravitational force in the downward direction. That is why the top part is more elongated. It also implies tension in the string is not uniformly distributed, but it is greater at the top than at the bottom. In this position, the forces acting on the suspended Slinky are in equilibrium. That is, the downward pull of gravity is balanced by the upward pull of the tension in the coils. Let's see the animation of the Slinky after the top end is released. So, what does happen? The top part starts to collapse, moving in the downward direction. This is an expected behavior as the restoring force has caused this, so not very interesting. But what is interesting is that the bottom part doesn't move at all during the whole collapse of the Slinky. Why so? Why the bottom part keeps levitating? It seems bottom part defies the gravity. This unique behavior of the Slinky makes it an interesting demo for students. You would also have noticed that the motion of center of mass of the Slinky, shown by the red star, at this point the whole weight of the Slinky acts, and it moves downward with the gravitational acceleration g. This simply follows the free fall motion under gravity. What is the physics behind this behavior? Why does the bottom end keeps levitating? I give you the basic idea here. When the spring is released, a compression wave is produced, and it takes time for the wavefront to reach at the bottom. Compression waves are just like other waves in physics, and takes time to propagate from one point to the other. These waves are common means of energy transfer or disturbance in solids from one point to the other. When a Slinky is released, it is sort of disturbance, so is communicated to the bottom through compression wave. In Slinkies, these waves can take almost half a second, so can easily be observed. That is the reason the bottom part keeps levitating until this information is reached at the bottom end. The motion of different parts of the Slinky can be seen more clearly in this diagram. Horizontal axis is the time and vertical axis is the height of the Slinky. It demonstrates that the top part, shown in the green line, starts to go down after its release. The red line is the bottom and doesn't show any motion unless the top part is fully collapsed. Blue line, showing a parabola, indicates the motion of the center of mass of the Slinky, and it simply follows the free fall motion under gravity. Remember, this is one of the simplest model of the Slinky. This is based on considering restoring force and gravitational force coupled with the wave equation. It is based on a paper given in the description. I will talk that more in some other video. Hopefully you liked the video and thanks for watching it.